guys. Apologize that I'm not here today, but I do need you to make sure you get these notes done and go through some of these guided practice problems and be ready to roll with this when I return. Don't forget to turn in reassess items like your homework if you have to do the odds to reassess a homework packet, or quizzes, do your corrections. But when I get back, we're going to go into triangle midsegments. This is going to be the breakdown of the definition, the properties, and the coordinate application. So a midsegment, your definition basically, a midsegment is of a triangle, a midsegment of and I'm just going to do my delta symbol, of a triangle, basically just joins the midpoints of two sides, okay? So it joins the midpoints of two sides of a triangle. Alright, so there are some properties that go with this, but you have to be able to identify that off of a figure. So the example that you have over here, first of all, notice that these tick marks pretty much are identifying that Q is the midpoint, and so is P, because I'm just going to abbreviate that midpoint. There we go. And because we identify that those are midpoints, then we now see that PQ is a midsegment of the triangle LMN. Okay, so there's your example. Make sure you see the tick marks. I notice that they won't be the same on both sides unless we're dealing with an equilateral triangle. And then our properties, there's a couple of facts or properties you're going to have to identify or use when you're doing some midsegment problems. So the first thing is a midsegment is always parallel. And I'll spell it this time. To a side of a triangle. Oops, that's ugly. Sorry. And so in our example up here, PQ is a midsegment, so it's going to be parallel to LN. Okay. And then another property, in which this is probably the one we're going to apply the most, let me scoot this up a little bit, is that its length. When I'm talking about a midsegment, its length is going to be half the parallel side. Half the length of the parallel side. Or you can think of it like this. Another way, the way I like to use it, I think this is the easier representation. You can think of it, if I double the midsegment, it equals the parallel side. Okay, so if I double it, it will equal the parallel side. So we're going to take that relationship, and especially the parallel, and still use the properties with parallel lines to problem solve. And that's kind of going to be shown to you in this example here. So I'm hoping you see, because of the tick marks, we see that we have some midpoints right here. Midpoint, right? Okay. So that means that 54 is going to be parallel to the 3x. And now that I have parallel, I'm going to start with 110 and y, because 110 plus y is going to equal 180, because we have same side interior. When I'm dealing with parallel lines, I'm still going to deal with corresponding, alternate interior, same side interior. So I'm hoping you see real simple that y is 70. So, because they want us to find the value of each variable. All right, so y is 70. And then, since 54 is the midsegment, okay, I can say that 54 is half the length of 3x, or I can talk about it in a reverse relationship. If I double 54, it just equals 3x. And I like saying double because then I don't have to worry about dealing with fractions. So basically I have 108 equals 3x, and then we're going to divide by 3, and so 36 equals x. Okay? And then if I want to find Z, well, I see that we have it's a midpoint here. So basically 48 is equal to 4Z. And then I think I automatically see that Z equals 12. That's horrible, sorry. Alright, so we're going to use all the relationships, prior knowledge, in regards to parallel lines, to help you problem solve. So you're going to also look at midsegments on the coordinate plane. And you kind of already did this on the last worksheet when you had to do midpoints and distance formula. That was due, I think it was due Thursday. So the first thing you're going to do is you're going to always graph your points and label them. So we got -5, -5. So that's that point, that's A. And then we have -3, +5, that's B, and C is 7, -1. And that is C. Alright, so we're going to create the triangles, this graph triangle ABC. A, B, C. Alright, kind of crooked, but. Alright, it says find and graph D, the midpoint of AB. Well, even if I didn't physically see this, I could use the slope, but I'm hoping you can see it right there. That is D. It's the midpoint of AB. So I'm going to put the little tick marks. And this is find and graph point E, the midpoint of BC. Well, even if I couldn't see because my graph is a little off, I could just look at my slope. If I look at the slope of BC basically is going up 1, 2, 3, 4, 5, 6, and to the left 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going to do half of that. So that's going to be 3, 1, 2, 3, 1, 2, 3, 4, 5. And there is my midpoint E. But you can physically see that. All right, so then they just want the coordinates of D. So D was a -4, 0, and E was 2, 2. So DE is also, when I connect it, because these are midpoints, and a segment connecting that joins the midpoints of two sides of a triangle is a midsegment. So DE is known as a midsegment. Now, the slope of DE is going to equal, well, we can physically count that. We can do the rise over run. So that's up to the right 6. I hope you can see that. Well, 2, 6 can be reduced to 1/3. All right, so the slope of DE is 1/3. It says without actually finding it, what would the slope of AC be? Well, since we're dealing with the midsegment, okay, the midsegment has a property that states that it will be parallel to a side. So I should know that automatically AC is 1/3. How do we know that? Well, DE is a midsegment. Sorry about that. And therefore, 3 dots, like a triangle. DE is parallel, segment DE is parallel to segment AC. And this is one of the properties of a midsegment. Excuse me. Okay. All right, so now we're going to do some practice problems, some application, with some algebra embedded. So let's go to the next page. First, they just want you to name the 3 midsegments. Every triangle has 3 midsegments. So if I look, we see that we have, I'm hoping you can identify them, MP. Okay, you also have MN, and we also have NP. Okay, so what segments are congruent by definition of midpoint? Well, we're just trying to find the parts that are being bisected by the midpoint, and then just find our 2 congruent parts. So we can say AN would be congruent to NC. I can see they have the same tick marks. I could also name AM is congruent to MB, and MP is congruent to PC. Alright, so you will be given some coordinate geometry application of midsegments without a graph. Okay, so it's find the midpoint of D of AB and E of BC. So because we did midpoint formula just a while ago, we can find the midpoint just using the midpoint formula. So D can be found by doing x1 plus x2 divided by 2, y1 plus y2 divided by 2. I'm going to give you, go ahead and try to do the midpoint of AB. So we're using the coordinates A and B to find the midpoint of D. I'm hoping you say 0 plus 2 divided by 2, 2 plus 10 divided by 2, D is the coordinate 1, 6. Now, they want us to do the same thing for E. E is going to be the midpoint for BC. You can pause the video if you want to. I want you to try that part, and then I'm just going to give you that coordinate. So now they want us to show DE, segment D is parallel to AC. So in order to do that, I just need to show the slope of DE. And that's just going to be my y2 minus y1. So basically I'm going to do my 5 minus 6 and x2 minus x1, 7 minus 1. We get a negative 1 over 6. So that's my slope of DE. And we want to show that they're parallel, so I need to go ahead and find the slope of AC and compare those slopes. So I can do 0 minus 2, 12 minus 0, negative 12, or 2 over 12, which can be reduced to negative 1, 6. And then, because we have the same slope, so we know DE, or we have proven DE is parallel to AC. Okay, so using your slope formula, use your midpoint formula, and using your distance formula, because anytime I see two letters written side by side, that's showing distance. So here they're asking us to find the length of DE, and to do that, I'm going to have to use the distance formula. So basically, x2 minus x1, so I'm going to do 7 minus 1, parentheses squared, plus 5 minus 6, parentheses squared. And we're going to get 6 squared plus 1 squared, which comes out to be the square root of 37. Okay, I'm going to just keep that. That can be simplified. Well, I'll tell you why. And here in this, I know you can put a decimal, approximately 6.08 with 6.1, but because we're trying to compare to see if DE is double 2 times D equals AC, I'm just going to keep this, because I can see if it's being doubled or not a whole lot faster. So I'm going to find the length of AC doing the distance formula as well. So this is 12 minus 0, parentheses squared, plus 0 minus 2, parentheses squared. Basically, we get 12 squared plus 2 squared. That gives me a square root of 148. And this can be simplified. Okay, 148 is 4 times 37. And I'm going to take the square root of that. But 4 is a perfect square. Square root of 4 is 2 times 37. And then I can physically see that if I double DE, it will equal AC, 2 times the square root of 37. Okay. Now, we're going to apply mid-segments algebraically as well. I will have to tell you that the points on this triangle are midpoints. So they're telling me that D is a midpoint, so I'm going to go ahead and put my tick marks. E is a midpoint, 2 tick marks. F is a midpoint, let's do 3 tick marks. Doesn't say that they're all the same. And DE is going to be the 4x plus 5. And J is, so let's do this, 4x plus 5. And then GJ, this whole segment down here, 3x plus 25. Alright, so hoping you see that the midsegment property says DE, the length of D is 1/2 the length of GJ. Or I can say if I double the DE, the length of DE, it would equal to the length of GJ. Oops, gotta make that a J. And of the two, I'm going to do double because I don't have to worry about the fraction. So basically, I'm just going to substitute the parts there. I'm going to do 2 times the 4x plus 5 is going to equal to the 3x plus 25. and we're just going to solve for x. Just distribute. Go ahead and give you some time to do that. Distribute and solve for x. I know you can do this. Alright, so you got x is equal to 3, so they want us to find the length of DE. Find DE. Well, to do that, I'm just going to substitute it back in. So 4 times 3 plus 5 gives me DE of 17. Alright, so that is the test like, and so are quadratic practice with Midsegment. So on this last page, I'm going to go over a couple with you. And I'm going to have some of you finish them on your own, and I'm going to check this. This is what I'm going to really check to see if it's completed or not. So we know that ZO is a midsegment. It says it right here. So we know it's parallel. And we also know that if I double ZO, it's going to equal to TA. All right? Well, I know that TA is equal to the quadratic 6x plus 3x minus 2, and ZO accordingly 2x squared minus x plus 5. They want us to find the length of ZO. So I'm just going to go straight into substituting. So we're going to do 2 parentheses 2x squared minus x plus 5 equals 6x squared plus 3x minus 2. All right, we're going to distribute here. When I distribute, I get 4x squared minus 2x. Got that. Plus 10 equals our 6x squared plus 3x minus 2. All right, these are quadratics, and in order to solve this, it has to be equal to 0. So I'm just going to go ahead and subtract the 4x squared. I'm going to go ahead and add my 2x. And I'm going to go ahead and subtract 15. No, not 15, 10. Sorry, I just saw that. Apologize. Subtract the 10. Alright, so this all cancels out. I get it equal to 0. 6x squared minus 4x squared leaves me with 2x squared plus 5x minus 12. Okay, now let me talk about this real quick, because this is a little different than the factoring we did before. Our factoring we've done in the past did not have a coefficient in front of x. Now we do. And so I'm going to talk about factoring by grouping. You can do the box method. I'll probably go in more detail with that in class when I see y'all. So the first thing, whenever we have a coefficient in front of the x, the easiest way to factor, to come up with the factors, is take the coefficient in the first term, multiply by the last term. That gives me a negative 24. So I want factors of a negative 24 still with the sum of b. That's the middle term, which is 5. So basically, I know I can do positive 8, negative 3, and that still gives me 8 times a negative 3 gives me 24, and 8 minus 3 gives me 5. Now, when I say I prefer to do factoring by grouping, is because I know that these factors, the 8 and the negative 3, gives me the 5x here. So what I'm going to do, I'm just going to keep what I have, which was 2x squared. And now instead of doing 5x, I'm going to say the 8x minus the 3x would give me that 5x minus 12. And now I can group it, first term and the last term, and think of that negative sign being with that 3x. So let me write this so y'all can see it a little bit better. I don't want this to confuse you. Minus 12. Right? It was minus 12. Alright. Alright, so anytime you factor, you're always trying to find the greatest common factor. There wasn't in that first term the 2x squared plus 5x minus 21, because we got odds and evens. But if I look at the first two, they have a 2 and an x in common. So I'm going to come over here so you can see what I'm doing. So I'm going to factor out the 2x. That's going to leave me with an x plus 4. And then if I do the same thing, the greatest common factor between the 3x, the negative 3x, and a minus 12 is a negative 3. So that's going to give me x plus 4. And then if I look, the reason why I want to do by grouping, this is the common factor, the x plus 4. So my factors for 2x squared plus 5x minus 12 solve are the 2x minus 3, the coefficients outside of the parentheses, and the x plus 4. And then when I solve this, I'm solving each term, each grouping equal to 0. And I know I'm running out of room here, but this 2x minus 3 is equal to 0, and this x plus 4 is equal to 0. So basically we have x equals a negative 4, and we have x equals 3 over 2. And then to solve or to find the length of ZO, you plug it back in. It is possible to have two answers because we have two values for x. Now, your challenge and what I'm going to check for is for you to do number 2, same type, and this one's nice and neat because it does not have a coefficient in front of the x squared when you solve it, but just a reminder, if you double the ZO, it equals the TA. Now, you can just substitute and solve and factor. Make sure your quadratic equals to 0. But on number 3, you are going to have to pay attention to the coefficient in front of the x. So we will finish, or I will check number 2 and 3 on the notes packets. Thank you for taking the time to get this done. I will also be doing the same thing for your little practice that you're going to do with this. All right. Y'all have a good weekend.